It's just molar mass is different. But when you mix that solid in water, the water vibration is mixed with water already. So it's, we have the molarity, we have the volume. Molarity times volume will give you one. Yeah. Yeah.
Oh,
All right.
I was thinking about it. I guess it's, well, it's not really that one. I mean, I think you don't really do that. You can do it if you want. I was that. It was still stem, but I chose. But I don't actually know if this is.
Right. I'm confused on
Yeah.
because I intended to do it and I can't.
Infrared radiation is looking at that.
Yeah. Other than that, dude.
Okay.
Everything else is.
Right.
So we know the wavelength. And we wanted to get one more multiple. So E equals to HC over lambda. We need to do H is the compound and C is the speed of light. This needs to be converted into meters. What's given is the nanometer. Okay. And this is the energy carried by 1 photon. 1 mole. Well, times 6.02.
Oh, yeah.
So the lambda converted into meter, and then H and C are constant. This is the H.
Everything I
You should have known that.
really so stressful. That's right. Yeah. And you see it, I want to
and we're going to get started with another chapter there. Now that we know how the electrons are being distributed, we want to look back and then re-examine what we call the periodic properties there. Now, all along, we've been talking about the chemical properties there, and we're trying to determine the chemical properties of different atoms and of elements there. And then what dictates the behavior of atoms is really how the electrons are being distributed. So the quantum theory helped us to solve that problem. Now that we understand how the electrons are being distributed, we are going to look at the what we call the periodic properties of elements. So remember in chapter 2 when we first introduced the periodic table, we say, well, some elements are metals, some are non-metals. So you have main group elements, metal elements on the left side, main group non-metal elements are on the right side, and then in between you have your transition metal. Why do we categorize it that way? And can we arrange them differently? Well, we need to look at the electron distribution. What determines how the elements are being arranged in the periodic table really has something to do with how the electrons are being distributed. So in chapter 8, we're going to look into the periodic property. And we want to understand, based on electron distribution, there are certain properties of those elements that are repeating itself periodically. So that's the focus of chapter 8 there. Now, talking about the periodic property, we have to mention this Russian chemist Mendeleev. He was making an observation based on what we know about the atomic numbers and the number of electrons at that time. And he made an interesting discovery. He said, well, the elements that we know of in nature actually has an increasing, well, different elements has a different number of protons there, or atomic number at that time. We call it atomic number. It's actually the number of protons in there. And then he made some arrangement. He said, well, what happens if I start with the proton number equals to 1? And then the next element that we know of, and